Given the sine of an angle, and knowing that that angle is between 90 and 270 degrees, let's determine the tangent of 2x. First thing we'll want to do is we will want to figure out which quadrant angle x is in. It's in quadrant 3. We know this for two reasons. First of all, the angle is between 90 and 270, which puts us between quadrants 2 and 3. That's the first reason. The second reason is this. The sine is negative. The sine is not negative in quadrant 2, nor is it in quadrant 1, which doesn't concern us here, but it is negative in quadrant 3. So that's how we know. Now with respect to the reference angle, which I'll call x sub r, we want to identify the sides of a triangle. Since the sine is opposite over hypotenuse, that's 3 over 4, we labeled the opposite side negative 3 and the hypotenuse 4. Let's go ahead and use the Pythagorean theorem to get that third side. And if you're thinking 3, 4, 5, you're forgetting the 5 has to be the hypotenuse. So we'd actually have to use the Pythagorean theorem here to get that third side, and that would be the square root of 7. Okay, let's go ahead and write our formula now for the tan of 2x. That's 2 tan x over 1 minus tan squared x. Now the tangent is what we're going to need to determine, and the tangent is opposite over adjacent, so that's going to be negative 3 over negative the square root of 7. So that's the top, and then for the bottom it's going to be 1 minus the same thing. Okay, let's clean this up a little bit. On top you get 2 times negative 3, which is, 2 times 3, which is 6. By the way, negative and negative is positive, so that's why you're not seeing any negatives there. On the bottom, since we're squaring here, negative 3 squared is just 9. And when you square root this radical, you just get the number. So that's just 7. Okay, now here's what we want to do. In order to clean this up, what we want to do is we want to simplify this complex fraction so that we just get one fraction on top, which, by the way, we already have, and then just one fraction on the bottom, which we don't have. In order to make this one fraction on the bottom, we're going to need to get a common denominator. So how about we rewrite that 1 as 7 over 7. Okay, let's clean up that numerator a bit. We get 7 minus 9, which is negative 2. And on top, we want to rationalize, so let's multiply top and bottom by the square root of 7. And just like that, now we're ready to do the next part, which is this. Now that we have one fraction over one fraction, what we want to do now is we want to go ahead and divide. Now recall that if you're dividing two fractions, namely this one divided by this one, what you're really doing is you are multiplying by the reciprocal of this guy on the bottom. So we want to flip that over. Therefore, we end up multiplying this top part here by 7 over negative 2 instead. Now, from here you should see some reductions. 7's reduce out to give you 1 and 1. 6 and 2 reduces as well. We wind up with 3 and negative 1. So that's really it. Okay, let's do a proof involving double angles. Let's verify that the cotan of 2x plus tan x is equal to the cosecant of 2x. Recall that proofs get easier when you rewrite them in terms of sine and cosine. So let's go ahead and do that right now. We'll start off with the cotan 2x. That's cosine of 2x over the sine of 2x. The tangent is the sine over the cosine. And over on the right-hand side of this, that's 1 over the sine of 2x. Okay, now what happens next is this. You might notice that we have like a mixture of angles. We have a double angle and we have a single angle. Whenever you have this kind of situation, you will want to immediately introduce all those double angle formulas. So that way we can have everything in terms of the same kind of angle, which is a single angle. The cosine of 2x is cosine squared minus sine squared, and the sine of 2x is 2 times the sine times the cosine. Same thing over here on the right-hand side. Therefore, on this right-hand side, we want to make sure that everything on the left becomes 1 over 2 times the sine of x times the cosine of x. Oh, and we mustn't forget the sine over the cosine. We need some more space here, so how about we take this right-hand side and drag it over. So we'll just put it way over here. Okay. Now, you should notice that the right-hand side is just one term. So what does that tell you to do? Well, what it tells you is this. If the right-hand side is just one term, that means that you want the left-hand side to also be one term. And the way we do that is to make it into one fraction. And we do that by getting a common denominator. You'll notice that down here it's 2 sine cosine. Here it's just cosine. So let's go ahead and multiply this fraction by 2 sine x. Doing this allows us to have both with the denominator of 2 sine cosine. Okay, so starting with the first part, nothing here has changed, except now what I'm going to do is, since I have a common denominator, both have 2 sine cosine, I'm going to rewrite the whole thing over this one term. So cosine squared x minus sine squared x, that's what you see here. If you multiply these two together, on the other hand, what that gives us is 2 sine squared. Okay, let's go ahead and collect like terms up top. These two are like terms, so you have 2 sine squared and negative sine squared, which just gives us positive sine squared. And hopefully you recognize these two terms as being 1. And there you have it. Again, I want to reiterate that typically it's easier to change to sine and cosine, and also that if you're seeing double angle formulas mixed in with single angle, you want to immediately substitute in the formulas for those double angle trig ratios. Alright, let's do one more. Let's use the double angle formula to verify that the cosine of 120 degrees is equal to negative 1/2. Since it says cosine, let's focus on the double angle formula for cosine. And this is one of them, cosine squared minus sine squared. What that means is that it's cosine of 2 times an angle. Whatever that angle is, that simply goes here and here. The angle is 120 degrees, so you have to think, what's 120? Well, 120, if you're using a double angle, would be 2 times 60. So this is how we would apply the formula. The cosine of 2 times 60, which is 120. So that'll be the cosine squared of 60 minus the sine of 60. Since 60 is a special angle, why don't we refer to the 30, 60, 90 triangle to help us evaluate this. The cosine of 60 degrees is adjacent over hypotenuse. That's 1 over 2, and since it's squared, we square the whole fraction. And the sine of 60, which is root 3 over 2. Now let's go ahead and square these. Typically when you square a fraction, we square both the numerator and the denominator. This first fraction, if you square 1, you get 1, and if you square 2, you get 4. For the second one, if you square the square root of 3, you just get 3. Now this is easy arithmetic from here. These already have a common denominator, so just 1 minus 3 is negative 2, and that in turn reduces to negative 1/2. And that's it. That's it for this one. I'll see you next time.